Thanks for coming to my session. Thanks for coming to SQL Bits. Power Query. Who loves Power Query already? Good. You have to. This is a difficult slot to do. There are a lot of other good sessions on that I wouldn't have minded seeing. So thank you for coming to see me. Let me introduce myself. My name's Chris, and I am a consultant and trainer, hitherto specializing in analysis services and MDX and DAX, but now adding a new string to my bow. I like Power Query as well. I'm a blogger, I'm a SQL Server MVP. I have co-written a couple of books, including a new one on Power Query, out now. What are we going to cover? Well, I'm going to assume in this session that you have already seen the basic introductory Power Query demo. Am I right? Yes. I'm seeing lots of nodded heads. Good. There will be a quick recap of Power Query, but not a very long one, right at the beginning, during which we will make sure that you know all of the terms that I'm going to be talking about. And then after that, we will be spending a lot of time looking at M and the cool things that you can do in M. We'll be looking at a lot of boring code, and I will try and enliven it with jokes and song and dance and things, but I can't promise that there will be lots of pretty pictures that you'll get in other Power BI demos. So what is Power Query? I often think that Power Query gets a bit of a rough time when people are demoing Power BI, because of course when you're doing a keynote style demo of Power BI, everybody loves to see those flashy maps that you can build in Power Map, all of those wonderful dashboards you can build in Power View, and talk about, oh, here I am crunching a 1,000,000 row table in Excel, blah, 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 blah. And you know, at most you might get 1 or 2 seconds of, oh, and I loaded the data in using Power Query. But in my experience, for the people who actually take the time to look at Power BI, Power Query ends up being the part that they like the most. So that was certainly my experience. For me, it's not flashy, it's not cool, but it does the job well. It has some great functionality, and it's being updated every month. So even as I speak, the development team are getting ready for a new release of Power Query with some even more new cool features. What is Power Query? Power Query is a tool for loading data into Excel from multiple data sources. It's an Excel add-in. It's free to use for anybody that has got Excel 2010 or Excel 2013 Professional Plus. There is one important feature we'll talk about in a minute that's only available in Excel 2013. I'm going to be doing all my demos in Excel 2013. It's part of the Power BI suite of tools, but you do not need a Power BI subscription to the cloud-based Power BI stuff in order to be able to use Power Query. But if you do have one, there will be other cool things that you're able to do with Power Query, and we will see some of that as well. So let's do a very, very quick introduction to Power Query. I have an empty Excel 2013 workbook here, and I have the Power Query add-in installed. And I'm now on the Power Query tab in the ribbon. Here are all of the different places that I can get data from. I could go to SharePoint, OData feeds, HD Insight. I could get data from CSV files and XML files. I can get data from the web. I'm going to be very boring, and I'm going to go to SQL Server. I'm going to connect to my local SQL Server, go to the AdventureWorks DW database, click OK. And here are all of the tables in the AdventureWorks DW database. And I'm going to choose the date dimension table. Nothing really very interesting, a very standard date dimension table that you'd find in any data warehouse. I'm going to click the Edit button, and the Power Query window opens. So Power Query is an Excel add-in. It has a new tab on the ribbon, but all of the interesting stuff happens here in the Power Query window. So here is the data from the dim date table, And I can do all kinds of cool stuff in here. I can filter the data, I can transform it, I can add columns, I can do calculations, all kinds of stuff. So there's a whole bunch of columns here that I'm not really interested in. So let's select all those to clean those out. Select them, right-click, remove columns. I've got a bunch of years here, but maybe I don't want the data for the year 2001, so I can uncheck 2001 here. And now I say, well, I'm interested to see how many days there are in each day of the week. So how many days have I got that are Tuesdays? How many days have I got that are Wednesdays? So I can right-click on here. I'm going to group by. I'm going to say, give me the count of days. I've done a group by type query, basically the same thing that you can do as a group by query in SQL. I've got the data in the format that I want. I can see there are 144 Wednesdays in my date range. And now I can say, well, where do I want to load this data to? Because I'm running Excel 2013, I've got two choices. If you're using Excel 2010 or Excel 2013, you can always load the data to a table in the worksheet. If you've got Excel 2013, you can load data to the Excel data model. And the Excel data model is the bit of Power Pivot that is now native to Excel. It's that in-memory column store database that you know and love from thousands of demos on Power Pivot in the past. I'm just going to use Load to Worksheet here, click Apply, and my data is loaded into the worksheet. If I want to edit, I right-click, Edit, and I'm back in the Power Query window here. So this is all stuff that I'm sure you've seen and you know already. Let's get some terminology worked out first. What I've got here is a Power Query query. I don't know who thought that was a good idea, because now we've got to talk about Power Query queries, but just understand that the unit of work in Power Query is a query. A query is made up of one or more steps, and each step that we can see here is something that changes our data. It applies some kind of transformation to the data. The last step is the output of the query. So grouped rows is the output of the query. If I click on a step here, I can see the data at each point in the step. I can edit if I want, but understand that a query is made up of one or more steps. All right, that's the end of the beginning. Let's get beyond that. Now, I think that Power Query is really cool for regular users. You know, people that work with Excel for a living, people who aren't programmers, who aren't developers. You can do an immense amount of useful stuff in the Power Query user interface. The thing that I like about Power Query is that for somebody like me who likes to get their hands dirty, who wants to kind of go underneath the covers, then Power Query also gives me a lot of power and flexibility. Power Query is just a wrapper on top of something a lot more powerful. And once you get below the wrapper, you get to be able to do much more stuff than you could ever do in the user interface. So what is it underneath the surface? Power Query is really a user interface on top of a language called M. M is the unofficial name for the language, but it's what everybody refers to it as. M was developed as a language for manipulating data for a completely different project. It ended up just getting repurposed and turned into what's now Power Query. M is a functional language like F#. So the bad news about M, and this is one of the few things that I feel a bit disappointed with Power Query, is that while it's powerful, while it's great for developers, it's not something your end users are probably going to feel comfortable doing. It's not consistent with Excel formula language. It's not consistent with VBA. It's not consistent with DAX. It's not consistent with anything else that we would have normally associated with Excel. That doesn't mean that it isn't a lot of fun to work with. It's just maybe that you need to think about things in a different way. Now, we know that a Power Query query is a job. It's something that does something. We can also see the M that goes underneath each Power Query query. We can see the M for each step in the formula bar in the Power Query query window. So if we go here, here is my grouped rows step, and up here in the formula bar, we can see the M code that applies this step, that does that group by expression. So we've got something here that says table.group by English day name of week, and do a row count on count of days. So up here in the formula bar, we can see the M expression used for each step. We can edit things here as well. We can also see the entire M code for our query. So if we go back to Power Query here, and I go to View, and then click the Advanced Editor button up here, a window opens and shows me all of the M code for my query, and I can edit it here. Now, I suppose in a way this is the advanced editor, but it's not a very advanced editor. It's basically a text editor. They've got some reasonably good error messages in their defense, but there's no IntelliSense. There's no help. There's nothing that you'd expect from a kind of modern development interface. You're flying blind, which is maybe adds to the excitement here. But here I can paste any code that I want. And in this session, we're going to be spending a lot of time pasting code into the advanced editor window. So let's learn some M, because M is where all the fun starts. We're going to start at the very, very beginning. M, well, the two most important concepts that you need to learn in M are the concepts of expressions and values. Expressions are things that can be evaluated to return values. So 1 + 1 is an expression, and it returns the value 2. Values can be primitive types like integers or text, or they can be things like tables or list objects or functions, as we'll see in a minute. Now, the first important thing to understand here is that a Power Query query consists of a single expression. And that expression, when evaluated, gives you the output of the query. So the table that comes out is the value that the expression evaluates to. We do not have to always output a table. If we output a table, or we output something, then, and we put it into Excel or the Excel data model, it's going to be kind of forced into the shape of a table. But a Power Query query does not always have to return a table. So for example, let's get rid of that. And let's open a new workbook. So this workbook has got a single Excel table in here, but I'm not going to be interested in that just yet. I'm going to go to the Power Query tab, and I'm going to create a new query, but I'm going to use this option here, from blank query. So this is going to give me a blank query where I can write whatever code that I want. So let's go down here, blank query, and let's go to View. There is the code for a blank query. I don't want that. I'm just going to write the expression 1 + 1. I click Done, and you can see here, unsurprisingly, it's giving me the value 2. So my query here is returning a value which is an integer 2. Nothing else to say here. But just remember, a query does not have to return a table. It can return any kind of value. Now, if you look at the code that's generated by the Power Query user interface, that always comes in the form of a let expression. And let expressions are very, very useful. Let expressions allow you to have a single expression that is composed of multiple named individual expressions. And these expressions can then be combined. They are the steps that you see in your Power Query queries. But again, we can write our own let expressions inside the Power Query query window. So, how does a let expression work? Let's go back to the advanced editor. And I'm going to say let in. So I'm going to create something called step 1, 1 plus 1 in step 1. So in a let expression, I'm allowed to have a series of named expressions. They're kind of like variables. So here I've got something called step 1. It's going to give me the value of 1 plus 1. And then in my in clause, I guess, I have an expression that will be evaluated. Now, usually for the user interface, that's going to be the name of the last variable in the list here, step 1. So if I do this and click done, you can see now I have an applied step called step 1. I have one step in the user interface, and it returns the value 2. I can add multiple steps. So here I say step 2, and I can refer to the value that step 1 returns. So let's now have an extra variable here, step 2. That is going to be step 1 times 2. I return the value of step 2, and unsurprisingly, the value I get back is 4. Now, the in clause here can be any expression. So I don't have to return the value of step 2. I can return the value of step 1 if I want. I click done, and I'm now going back to returning the value of 2. In this situation, Power Query is going to realize that this is not used anywhere, so it won't evaluate the expression. It's not going to slow anything down. The only disadvantage of doing something smart-ass like this is that the user interface then breaks. It doesn't like not being able to return the last step. But I could do something here like return 5, 6, 7 and ignore anything else that's actually going on in my let statement. So let statements are very, very useful, and pretty much every expression that you write is going to include a let statement, and indeed every expression that the user interface creates will also be based around a let statement. Let expression, rather. Now, we've seen integers. You can work with text as well. That's not really very interesting. There are a couple of useful objects that you'll be working with in Power Query. The most important of which is a table. So obviously we want to import data. That usually comes in the form of a table. We want to be able to export data to the Excel worksheet, to the Excel data model. Obviously that is going to have to be in the form of a table if we're going to see it in either of those two forms. So there are a lot of functions that return tables. For example, if we get rid of that and discard, and I take my Excel table here, and I click the From Table button, what I have here is an expression that returns the content of the sales table in my Excel workbook. So this is a function. Excel.currentWorkbook is a function that returns everything in my workbook, and then I'm saying give me the table that has got the name sales table and give me the data in that table. So here we've got a function. Here is the table output. I click apply and close. and there is the table coming out. So tables are useful, but they are not the only type of interesting object that you may want to work with. We have lists. So let's have a look at this expression here. So I've got a blank query. And in here, what I've got are two expressions that return lists. Lists are, well, lists. They're ordered lists of things. In this case, I've got a list called fruit that consists of 3 names of fruit, 3 bits of text. And I've also got a list of numbers. The interesting thing is with my list of numbers, I can declare a list and say 1.5, and that list will give me all of the numbers from 1 to 5. So at the moment, my let expression is returning the contents of numbers. I click done, and I get a list which goes 1, 2, 3, 4, 5. I've got a button up here that says convert this to a table object, but I don't want to do that just yet. Just understand that this is just an ordered list of 5 integers. If I go back to the advanced editor and here return fruit, then I get a list containing apples, oranges, pears. Lists become very useful when you're manipulating data. When you're writing M expressions that will do more advanced things, you will be using lists all over the place. And it's actually very easy to get hold of list objects. Even though you won't get a list directly from a data source, you'll be able to do things like, well, give me all of the values in a column in a table, and you'll be able to get that as a list using the table.column function. We'll see that in a minute. So that's the first important object that we'll be working with. The second type of object is, well, the third type of object is a record. So a record is kind of what it implies. It's rather like a table with just one column in it. So here I've got a record with 2 fields, speaker 1, which is Chris, speaker 2, which is Marco. It's like I said, just like a table with 1 column in it. 2 columns in it, but 1 row. The first column is called speaker 1, the second column is called speaker 2. If we output this, then I get a record that says, well, okay, field 1, speaker 1 is Chris, field 2, speaker 2 is Marco. And we'll find records come up all over the place as well. If you want to get an individual row from a table, that will quite often come back as a record. So even though most of the time we'll be outputting tables, we also need to understand what these things called lists and records are. Because when we're manipulating data in tables, quite often we need to take part of the data in those tables and say, well, give me a list of all of the values in a column, or give me 1 row and let's work with that as a record. One of the other things, or probably one of the most basic things that we'll want to do once we've got a list, is get an item from a list. So give me the first item in the list. Give me the third item in the list. So let's see some examples. It's pretty straightforward. It's a 0-based array. So for example here, if I grab this and go back to the advanced editor, I'm declaring my list called numbers here. That's the list of numbers from 1 to 5. I'm saying give me the item at the index 2. It's 0-based, so this is going to give me the value 3. So that's the third item in the list, 1, 2, 3, 4, 5. If I edit this and say give me instead fruit 0, this will give me the first item in the list, fruit, which is apples. There are all kinds of interesting things that we can do with lists. Once we've got a list, we can say, well, let's filter it, let's sort it, let's aggregate it, let's do all kinds of interesting things to it. So typically, like I said, when you're working with lists, what you're probably going to be doing is getting a list of values from a column in a table using the table.column function. So let's see an example of that. So here in this query, my first step is that step that we just saw that said give me all of the data from the sales table in my workbook. And now here, what I'm doing is give me source 3. So source is the table that is stored in this variable. Give me the 4th row from that and give me the value in the month column. So I can address individual columns using this square brackets type notation. And now I'm going to get the value April, the 4th month in my list. And what else can I do? I can go away and I can say, well, let's grab all of the values in my month column. I promise it's going to get a bit more interesting in a minute. I know it's a bit dry, but once we've understood the building blocks, we'll get to do some of the cool stuff in just a moment. So here, get all of the data from my column called month, and now, because that's a list, let's get the second item in that list rather, which will be February. Now that I've got that list, let's now use list.count to count the number of items in that list. So how many values are there in the list that I've got from the column month? There are 12 months. And I can do stuff like, well, okay, get me the position of the value April. So list.positionOff says, okay, here's a list, get list. Give me the position of the value April in that list if it exists. And that's going to come back with 3. So this is all very, very straightforward stuff. It's just a matter of learning all of the functions. Now, speaking of functions, this is where things start to get exciting. Well, you get excited by this kind of thing. This is where you'll get excited. Power Query includes a whole bunch of built-in functions called the standard library. So Excel.currentWorkbook that we saw to get data from the current workbook, that's a function in the standard library. You can download a couple of big PDF files from the Microsoft site, the link's at the end of my deck, that will give you all of the functions that you can use in M. It's there online as well. But the point about M is that you can define your own functions. And functions are themselves a type. They're a value that you can return from a query. So functions are where you can start to do some really interesting stuff in Power Query, stuff that you cannot do in the user interface. So let's look at defining a function. It's very easy to define a function in M. This is a function that takes 2 parameters called x and y, and it returns x plus y. I'm going to click Done. I'm going to call this Add Numbers. And at this point, my query doesn't seem to return anything. It knows there's a function here, but there isn't any data. There's nothing that I could put into a table. If I click Invoke, I can use this function inside the current query. So if I click Invoke here, I'm going to get, I click properly, I'm going to get a dialog that says enter the parameters. Maybe let's enter 3 and 5. click OK, and I get the value 8 back. If we look at the code here, what's happened is that I've defined a step called add numbers. That step returns a function, and then in this step I'm invoking that function by returning the value of add numbers and passing in 3 and 5. So I get 8 back. So functions are interesting when you're writing more complex queries. You can define a function in one step and then you can reuse it in later steps. But that's not the really cool thing about functions. Let's get rid of that step that I just created where I invoked the function. Now at this point my query is returning just the function. But remember, a function is a value, and I can have a query return a value which is a function. Now, if I look at load settings down here, there's nothing that I can select. I can't load this to a worksheet, I can't load it to a data model. It doesn't return any data. But I'm going to click Apply and Close. Now here, in my Workbook Queries pane, I've got a function. And guess what? I can click on it here, and I can invoke it from the Workbook Queries pane, and I can enter some values here, click 10 and 5, and that will automatically create a new query, which will go away and return the value 15. I can also use this function, reference this function in other queries. So here is the query that I created earlier that gets all of the values from that table in the Excel workbook, my sales table. Let's add a custom column. And now let's call add numbers. Let's get the data from the sales column and add 10. So I'm calling that add numbers function that I defined as a separate query in this sales table query, and bingo, I have now got add numbers called for every single column, every single row in the table, and I'm getting 2 plus 10 is 12, 3 plus 10 is 13. So functions are really important when we start to do more advanced things in M. A couple of other things to mention very, very briefly. You've seen me do it already, but we can write comments in M. Unfortunately, you can't add comments through the query editor UI, so in that formula bar, for whatever reason, it just doesn't like you adding comments. But certainly if you're working in the query editor pane, you can add comments, and that's going to be a good thing. Single line comments, double forward slash, multi-line comments are forward slash asterisk, asterisk forward slash. We can also do a bit of error handling as well, which is good. If we're dealing with dirty data, we might want to do that. If we're doing certain types of calculation, we might come up with errors. So, for example, if we go back to what we were doing with positions, here is an interesting query. What I'm going to do here in this query is I'm going to import data from the sales table. I'm going to add an index column, and this is something I can do from the user interface. That just adds a column that has the value 0 for the first row in the table, 1 for the second row, and so on. So let me show you that. There's the first step, the data from the sales table. There's my index column with values 0 to 11. Now I've got this 0-based index column, again something I can do from the UI. I can now say, well, this 0-based index I could use with that position stuff previously. So why don't we, for every single row in this table, return the value for sales in the previous month? So if I write an expression like this in a custom column, I can say, well, give me the value of source, and then I'm getting the position of the value in the index column minus 1, and then get the value from the month column. So here for February, index is 1, take away 1 is 0, That's going to give me January, February, March will give me February, April will give me March. The only problem here is that I've got an error because there isn't an index -1. So let's get rid of that. How can we handle that? Well, I could just use the built-in remove errors button, and this will remove all of my errors. So let's just remove every row that has an error. But now, of course, we have a problem. I'm missing the data for January. So maybe what I should really be doing is something a little bit more robust. And I can use this try otherwise structure. So here what I'm doing is saying try source index -1 month. If that returns an error, if it doesn't return an error, give me the value it returns. Otherwise, return the value null. Click OK. And now we've got something failing gracefully. That looks nice. All right. Thank you for sitting through all the boring stuff. Now you should be ready to at least walk through some interesting and useful examples of things that you can do now that you know a little bit of M. So what I've got here are a number of worked examples. First of all, a really, really simple but useful thing you can't do through the user interface, but you can with a little bit of M. Parameterized data loads. So let's imagine we've got a big data warehouse. Let's imagine that we have users that want to be able to analyze that data in Power Pivot, in the Excel data model. The problem is we have a very, very big data warehouse. We can't load all of the data in to Excel. We're going to run out of memory. So what we want to be able to do is allow the end users to choose the data that they want. So to say, well, let's filter the data before we load it into the Excel data model so that we only get a small amount of data, a workable amount of data. Let's close this. So what do I have here in my workbook? I've got a table with one column in called day name. If I look on my workbook queries pane, I've got a query here called day name. We look in there and edit it. All it does is it takes the value from that table and it says just give me the value from the one column and one row in that table. So in this case, it's just going to give me the day name that I entered into that table. Nothing very interesting there. Notice, however, it's returning the text of the value. It's not returning a table. It's just returning the text from that cell. And I'm not loading it to the worksheet. I'm not loading it to the Excel data model. Now, what I've got here in this query is I'm saying, let's go away and get all of the data from the dim date table that we saw earlier in the AdventureWorks DW database. But now, let's filter the values in that table by the English day name of week column. And what am I filtering it by? I'm saying only give me the rows where English day name of week equals day name. What's day name? Well, it's that query that I just defined that returns that single day name in that table in the worksheet. So at the moment, it's returning just Monday. If I click Apply and Close, we get Monday. If I change this to Tuesday and go back to here and refresh, I only get the rows that are Tuesday. So I've got a very simple parameterized data load example. I could also take that query and turn it into a function. So let's have a look at this. Again, very straightforward. I've got a function that returns a table. The function takes text, a single text parameter, which is going to be the day name, and it does exactly the same thing. It says, give me all of the data from dim date, only the rows where English day name of week is day name. So let's close this, invoke the function, and I can say maybe Friday here, click OK, and it's going to go away to SQL Server, and it's going to give me a new query which invokes that function and gives me all of the rows in the table which are Fridays. So hopefully you can see how useful this is going to be for controlling data loads into Power Pivot. Now, let's think of another interesting example. I'm aware, who was on the Pragmatic Works, Adam and John Welch thing yesterday? Okay. I think they stole this demo off me yesterday. But at least now you'll understand how it works. What have we got here? Well, here is a query. Now, this query does not have a data source. What this query does is the following. It has two hard-coded dates, start date and end date at the beginning. And then what it does is it finds the number of days in between those dates. It then generates a list of dates starting at the start date and ending at the date we've specified. And then it does a whole bunch of stuff like calculating the day of the month, month of the year, day number of week, and so on. So if we step through this one by one, there's my start date, there's my end date, there's the number of dates between those dates. Here is a list containing all of those dates between the start date and the end date. Let's turn that into a table. Let's make that a date column. Let's add the day of the month, month of the year, the day number of week, all kinds of other stuff. And we've got a date dimension table that we can use. Now, this has got hard-coded dates at the beginning. What we really want to do, of course, is turn this into a function. So what I've got here is a function that is exactly the same query, only where the start date and the end date are now being passed in as parameters. Exactly the same code apart from that. And now here is a table with a start date and an end date in it. And if we look at this query, all I'm doing is getting the data from that parameter table at the beginning, start date and end date, treating those two columns as dates, and then saying, let's call my create date table function with the start date and the end date. And now I have a parameterizable function, parameterizable from values in my Excel worksheet, and just go away and give me a table of dates from the start date that I've specified up to the end date. So that's useful. What else can we do? We can call web services. Now, oh, that doesn't look good. Here is a function, and what this function does is it calls out to the Bing Maps API. Now, you may at some point see my Bing Maps API key hard-coded in this. Please don't copy it down if you're watching at home. But here I'm calling out to the API. I'm passing in a postcode. I'm calling to the API. I can use web.contents to get a value from a web service. I'm treating that as a JSON document, and then I'm saying, well, let's just go away, search through that JSON document until we get the latitude and the longitude from that back. So let's close that. Now here, what I should be doing is I'm saying, here is a table, I should mention that, from my worksheet with a bunch of postcodes in. Let's go away, and now we've got a function that takes a postcode and gets the latitude and longitude for those postcodes. Let's go away and call my function, which is called getCoordinates. So I should be able to go here and say, there's my table. Let's add a custom column. And if I say get coordinates, and I'm going to pass in the postcode. That's all I'm doing, calling the function. Click OK, and I have a new column with a table inside. I press the expand button up here, and bingo, I've got the latitudes and longitudes for my postcodes. If PowerMap was working on my machine today, I would be able to show you this on a map. But there we go. Now, I do have a more interesting example of calling a web service. But I have to be very careful here. Being a fan of Power Query, I built a Power Query workbook that connects to Reg Online. So here at SQLBits, we use Reg Online to handle all of our registration data. And we've got a web service that we can call from there. So what I did was used Power Query to go in and grab all of the data from Reg Online for all of the registrations, for all of the SQLBits conferences, so that we can analyze how registrations happen over time. So let's see how the curve of registrations takes place. This is some cleaned up, anonymized output, but we've got the number of registrations on the x-axis, on the y-axis, on the x-axis, we have the number of days since registration opened. This is SQLBits 11, this is SQLBits 12. You can see that the curve is more or less the same until here, when, for whatever reason, registration spiked. But the interesting thing is how I did this. Let's look in the workbook. What have I got here? I'm calling, in this case, the Reg Online API to get a list of events. So each SQLBits is an event. So let's get a list of events. The interesting thing here is we need some authentication, and Power Query is able to handle that. I'm able to actually store the API key not in the query, but in a secure credential store, which is associated with my machine. It's not associated with a workbook, so I could send the workbook to other people. They wouldn't get the API key, but they would be able to enter the API key into Power Query to be able to use this. And then I'm treating the response as an XML file, and I'm getting back a table with my list of events in. That gives me Reg Online's unique ID. And then what I did here was create a function that for each event, so pass in an event ID up here, go away and call the get registrations for event web service. That will get a list of all of the registrations for each event. So I get all of that back. So I get a table containing the registrations for each individual event. And then finally, and this is the bit that I realized at the last minute I can't show you because it's got actual people's names in, but I'm able to go away and take that table of events and then for each event get the ID and then call that function for each ID, get the table of all registrations back, and then combine that into a single table containing all of the events for all the registrations. Last worked example before we go back and do some slides. This is one of the first things I did with Power Query. It's one of my favorite Power Query demos of all time. Apologies if you've seen this before on my blog. But what have we got here? We have got a table with a list of words in and numbers. What do these words and numbers mean? Well, let's see what I've done. Edit my query. What's our source? Well, I went to Project Gutenberg and downloaded a text file containing the complete works of Shakespeare. And this is what it looks like loaded in as a text file. We start with the sonnets, and then somewhere later on there'll be the plays. It's only about 5.5 meg. Let's remove the line breaks. Let's remove all punctuation. Let's make everything lowercase. Let's turn that into a table with all that text in. Let's split those, split by white space. So now we've got a list of all of the words in the table. There's my list of words. You can see that's nicely in order. Let's turn that into a table. Rename the column word. Remove any blank values that happen to be in there. Now we've got a table, we can do a group by query on it. How many individual occurrences are there of each word? Let's sort that table in descending order and keep just the first 100 rows. And what have we got back? We have got the 100 most popular words that occur in the complete works of Shakespeare. So obviously the and are very, very popular, but if we scroll down, what else can we see? We can see the coming in at number 41 or whatever, and sir coming in and appearing 1,970 times. So these are all fun examples of things that we can do in Power Query. Now, before we finish, a couple of other interesting things to point out, good stuff that you get with Power Query. Let's talk about query folding. The interesting thing to note about Power Query is that it doesn't always want to do all of the work on your desktop. It is clever enough to realize that some of the things we're doing are probably going to be too complicated to do on the desktop. So where possible, it will always try and push the work back to the server. So for data sources like SQL Server, it will try and translate the entire query back into a SQL select statement. For some data sources like a text file, obviously you can't run SQL against a text file, so it will always load in all of the data and try and do the work in Power Query. But where the data source allows it, it will try and push the work back to the data source, which is a good thing, because obviously if you're getting data from SQL Server and you're doing a lot of hard work, you don't want to download a 50 million row fact table into Power Query and then try and filter it there. You want it to be filtered on the server before you download it. So let's see this happening. Let's go back to my parameterized data load example. And here, remember, is a parameterized query that just goes away and gets all of the values in the dim date table for the day name that we've specified here. If we run a profiler trace on SQL Server when this starts, so let's refresh this, we can see here the SQL that was generated by Power Query, and there we go, where first the English day name of week is Monday. So we can see this happening. So this is a good thing in general. We can actually stop this happening. There is a function called table.buffer, where if we don't want to always push the data back to the work back to SQL Server, we can use table.buffer to stop it happening. But there are other things that we can do that will also prevent it happening. Now, there are some types of transformation that we can do in Power Query that it just can't translate back to SQL yet. So when that happens, it will try and push as much of the work back to SQL as possible, but then it may be downloading still a very large table into Power Query. There are other things though where this will happen. For example, if you start combining data from multiple data sources in some scenarios, that can prevent this behavior called query folding. And also there are going to be situations where, for example, if you use your own custom SQL, which you can do to load data into Power Query, that prevents query folding happening. There's no indication in the user interface when query folding is happening and when it isn't, but if you are using Power Query on top of a SQL Server data source, it will pay to run a profiler trace and just to see how much of the work is being pushed back to SQL Server. Because using different functions, reordering your transformations could result in a massive difference in performance for your queries. Now, there is also one other scenario where you could be turning off query folding and not realizing it. If you think about it, query folding is a potential security risk. In that example we were just looking, I was taking a value from the Excel worksheet and then I was using that, or Power Query was using that value to construct a SQL select statement. And potentially somebody on the SQL Server side, a DBA, would be able to see the queries that were being run, and they would see a query with that value Monday in. Now, that could be a security risk. It could be a data privacy risk, especially if you're pushing values up to a web service. You don't know who's going to be on the end of this. So there is functionality in Power Query to turn this off or to control when this happens. This is called the Formula Firewall. It's much less obvious in the current build than it was in previous builds. In previous builds, it was quite intrusive. But at the moment, we are sure that query folding is happening. Now, what we can do for each data source is that we can go up to the data source settings here. And here I can see not only the credentials for each data source, but I've got the privacy levels for all of these data sources. Now these privacy levels have got different values. At the moment, my current workbook, that Excel workbook where I'm getting the day name from, is set to public. And public means that's fine, we can send this off to the data from this workbook off to whoever. If I change this to private though, and click done, let's clear our profiler trace and now refresh the query. What we will see is Power Query has generated a SQL query. Don't look at the order by clause. That gives me nightmares. I don't know why they insist on having an order by clause. But anyway, there is no where clause here anymore. Query folding is not taking place. It's downloading all of the data from the dim date table because that filtering saying only give me the rows in the table where we're matching the day name, that can now only happen on the desktop because I've marked my workbook as private. Now, it can be a little bit, it's not immediately obvious what these data source settings actually do, and you may inadvertently set stuff to private without really understanding what this means. There is also this option here, Fast Combine. Fast Combine simply turns off the Formula Firewall and says, I don't care about privacy, always give me the best possible performance. And when you do this, you can be absolutely guaranteed that query folding will take place whenever possible. But be aware that this is not a magic bullet. If you're working with sensitive customer data and you're sending it off to a web service and you think, oh, let's just turn Fast Combine on for the hell of it, you're potentially landing yourself in some big trouble if the regulators come around to see what you're doing. One very last thing, because I know that I'm running out of time. If you've got a Power BI subscription, you can share functions between multiple workbooks. So let's see a very quick example of this. I've got a function here. It returns the value version 1. I think this is going to be a useful function, a useful query. I can check any type of query, whether it's a query or a function. But I'm going to say, well, this is a really useful query. This is something I'm going to want to use in other workbooks. Now, here I have got a Power BI subscription. I'm connected to the internet. and I'm signed in here in Power BI, I'm going to be able to right-click here and share my query. I'm calling it Shared Query Test. I'm going to share it with everybody in my Power BI tenant. I can add a description. I can add a URL for some documentation, maybe a Word document. I'm going to share a copy. Up here in my Power BI site, on my Power BI page, once I've done that, I look at my queries, and there is Shared Query Test. Now, if I open up Excel, I can go to Power Query. I can do an online search, and I can say, where's that useful function that I shared earlier? Let's search for something called shared. Come on. Right, that should have come up because Shared Query Test is there. All right, come on. Now, if I can see this in another place, I've got my shared queries here. There we go. It should have turned up in the online search. It's probably not indexed yet. But I can then click here, use shared query, and get that appearing in another workbook. So you're able to upload a query and share it between multiple workbooks. The bad news about this is something I'd have demoed if I got time, is that it only shares a copy of the code. If you update the original query, then the shared copies do not get updated. You've got to delete and then re-download. So this might seem exciting, but at the moment it's not all that exciting. Hopefully this is something we have a better experience for in the future. But that brings me to the end of my presentation. Hopefully you've seen some of the cool, amazing, advanced stuff that you can do in Power Query. Here are all of the links. The slides will be available at some point, but here are the links to the Excel, the PDF documents describing the M language and all of the functions. There's something that you're going to want. There's a link to the online formula reference, which is less detailed, but maybe a little bit more handy. And here is a link to my Power Query book, which is out now, and 30% off the ebook price for the next couple of days if you use the code here. But if you email me, I'll come and get it. So thank you for listening. Go away and enjoy and do some advanced stuff with Power Query.